الأنبياء والمرسلين سيدنا ونبينا محمد وعلى آله وصحبه أجمعين. Today we are going to talk about speech perception and lexical access, and this is lecture 8. I welcome you all to this lecture, and I hope that you find it interesting and useful as well. Right. Now, if you look at this dress, it went crazy a couple of months ago, or maybe a couple of years now, and people were asking, what color is it? Is it blue and black? Is it gold and white? Different people saw this dress differently. And people asked questions like, why do I see it blue and someone else would see it white? Why someone would see it as gold? And so on. And the answer lies in perception. Perception. Now this is the key word that I want you to focus on today. Perception. So today we are going to focus on perception in regards to language. Now, after we have explained how language or how perception is related to language and how we perceive language, how we understand and comprehend language, you'll hopefully understand why people see this dress differently, or different people see this dress differently. First of all, we're going to focus on several topics in this lecture and in the coming lecture, lecture number 9. We are going to focus on perceiving speech. So how do we perceive speech? The constructive speech perception is also very important, and we are going to talk about that. So what do we mean by constructive speech perception? And phonological illusions. And then later on, we're going to talk about a bottom-up and top-down processing of information. Now, the hearer. At first, when it comes to language production, if you remember in the last lecture, we would start with what we call a pre-verbal message, if you remember. The pre-verbal message. This is what we start with. Then, after that, when it comes to language, the first operation was lexical access, if you remember. So first, we gather the words, like the girl pets the dog, and then, so this would be number 1, then this is number 2, right? And then phonology is number 3, right? So this is how it was when it comes to language production. Now today we are going to talk about something else. It's the opposite. If you think about it, it's the opposite. Let me erase this first. Let me erase this so that it's easy for you to follow. Right. Now, we are not thinking about production. We are thinking about, or we are talking about, the hearer. We are focusing about the hearer. We are focusing on the hearer, the one who hears. So, how do we perceive language? Not produce language. How do we perceive language? So, first of all, there would be some noises produced by someone else, like just random sounds. Then we would hear them with our ears, of course. And then the auditory system, like the ears and the associated parts of the brain, will send the whole thing to the phonological representation, or to the phonological component of language. So this is language, okay? This is language, and here we are talking about the ear. So you heard first this sentence, whatever. It goes to language, and first it doesn't go to the lexical access, choosing words, or syntax or morphology. No, first it goes to the phonological component of language. At first, here, whatever you hear is just random sounds following each other. Then the phonological representation would translate that into words or lexical access. So then the lexical or the lexicon would like alert you that this is a word. This is separate from this sound. This sound is separate from the sound, separate from the sound. Well, as you hear it, you don't hear words actually. You don't hear words. You hear continuous signal. You hear a continuous signal, just sounds. But your brain breaks them down. Or let's say the linguistic components or the language system or language would divide it at this stage, the second stage, would divide the words. So at first, they are not words. They are just, as you can see, continuous sounds. But then, after the phonological representation or component would translate it to words. After the words have been set, then the whole thing is sent to the syntactic representation. And here, where the syntax, semantics, and all of that take place. So here, we make meaning at this stage, syntactic representation. And then, as a result of that, as a result of this linguistic processing, we get the idea that the person wants to say. Like here, for example, the person wants to say, the girl pets the dog. So you see, it's very complicated. This is just processing of one sentence. This is what happens in the brain. First, we hear it, then it's sent to the auditory system. The auditory system sends it to the phonological component, which at this stage, the sound or the signal is meaningless, more or less. So it's just continuous noise, let's say. At this stage, the brain breaks the signal into words or lexical items. And we talked about the difference between words and lexical items before. Once we have the main words like girl, pet, dog, then syntax takes place. After syntax and morphology, we get the idea that the girl pets the dog. Right. Now, as you're listening now to this lecture or any other lecture, some people would think, well, it's easy. Yes, we can. Even in Arabic, you hear someone talking for 1 hour and you understand everything they say. And you might think, oh, this is an easy job. I can understand whatever I hear. But our goal in psycholinguistics is to explore how language is understood, how we perceive language. And as you can see here, extracting phonetic elements and words from a continuous, that's number one, unsegmented, highly co-articulated signal poses difficulty in speech perception and lexical access. What does that mean? Well, what you hear in lectures or classes in Arabic, English, or any other language is usually a continuous signal. So the person would be talking non-stop. Like, for example, think about lectures. Someone lecturing students, he or she would be talking all the time, especially in lectures, not tutorials or live sessions. But when it comes to classes or lectures, you have continuous signal. The person, doesn't stop talking. Listening to the radio is the same, or TV, watching TV is the same. So the signal is continuous. It goes on and on for hours, maybe. So that's difficulty number one. Then, that signal, which is continuous, is also unsegmented. Un means not, segment or segmented. So, basically when we speak, we don't speak word by word. And this is what I meant here. This is what I meant here. Right? So it's unsegmented. So we don't speak word by word. If you think about it, if we speak word by word, someone would say, for example, extracting phonetic elements and words from. So that's like machine talking, isn't it? But as I speak, as you speak, it's unsegmented. Sometimes you have 2 or 3 words, pronounced in one sentence, in one second, or maybe in a fraction of a second. So it's unsegmented. We don't speak word by word. We don't segment it. So that's number 2. This makes it difficult. This adds to the difficulty of the perception or the speech perception system. And then the signal is highly co-articulated. Co means together, articulated. So sometimes you'd have 2 or 3 sounds pronounced together. So this is co-articulation. To articulate is to speak, okay? So highly co-articulated, so the 2 sounds or 3 sounds, sometimes 2 words maybe, they pronounced together. So this makes it really difficult for the speech perception system to understand. So these 3 points here make it very difficult for the speech perception system and lexical access operations to extract phonetic elements and words. This makes it difficult for the brain, for the language system, to segment the signal or to extract phonetic elements and words from the signal. So again, what makes it difficult for the speech perception system and lexical access? What makes it difficult to extract phonetic elements and words? Well, 3 things. Number 1, the signal is continuous, it's unsegmented and highly co-articulated. Now, there are 3 features of the speech signal that the speech perception system must deal with. These are, as I said, the signal is continuous. Number 2, it transmits information in parallel, so co-articulated, as I said. And then it is highly variable as well. It's highly variable. The signal is variable. Sometimes you listen to someone speaking in British English. Sometimes another person would say the same thing, the same sentence, but using another form of English, so American English, South African, or whatever. And even in the States or in the United Kingdom, different people speak differently. So the signal is variable as well. Also, you hear different people talking at the same time, which makes it also very difficult for the speech perception system to extract information from. So these 3 features make it very difficult for the speech perception system to extract phonetic elements and words. So number 1, the signal is continuous. Number 2, it transmits information in parallel, and we're going to see in a minute what does that mean. And then it's highly variable. Different people speak differently, and yeah, so different people talking at the same time. The signal is variable. Now if we look at this figure here, this is an illustration of parallel transmission of phonetic information. Now this is a spectrogram of the sound bag, or the sounds, or the word bag. Bag. Now we are not talking about a whole lecture. We are not talking about an essay or a sentence. No, just a very, very small word, which is the word bag. It contains 3 sounds, right? As you can see here, we have 3 sounds, right? This is a spectrogram which shows you where each sound started, where each sound ended, right? Okay, so what do we see here? This square, the first one here, shows you the time this sound started, which is this sound here, right? Then this square tells you where this sound started. It started from here, as you can see, till there. Okay, so this is the spectrogram of the sound a. Okay, and here the spectrogram showing you where this sound started and ended. It started from here and ended there. So what do you notice here? Are the sounds produced at different times, or are they co-articulated, transmitted in parallel? And by the way, this here is the time in milliseconds here. All right, so this is time in milliseconds. So the word bag, let's say bag. Okay, again, it starts from here. Bag. All right, so bag, this sound the b sound started from here to there, and the second sound started from there to there, and this is the third sound, g, there and there. What we can see is that there is an overlap sorry, you just erase that. All right, what you can see here is that there is an overlap the 3 squares, like the overlap, which means that the sounds are not pronounced at different like times. No, they were co-articulated, so pronounced in parallel. Let's say the sounds are pronounced or produced in parallel together, which this diagram here shows you, or these squares. So this is just a word bag. So we don't say ba, a, ga, right? We don't talk like that. We don't talk in sounds. We don't say ba, a, ga, or for example ka, or say cat, for example. Okay, so we don't speak like that. We co-articulate. We produce words or sounds together. They are co-articulated. Now this, we say that in regard to one small word, which is the word bag. Now think about a whole sentence. A whole sentence being, co-articulated. All the sounds they contain are co-articulated. The signal is continuous and variable. So it must be really difficult for the speech perception system to make sense of what you hear. Now, we have another example which is more difficult, the dinner table talk. Dinner table talk. So when you are in a dinner with your friends or family, for example, and everyone talks, in weddings as well, where you have, for example, songs at the background, and you have people, a lot of people in the hall, and everyone is talking, but you listen to one person and you understand what they say. So it must be really, really, really difficult for the speech perception system to understand and make sense of what it hears. Now, as a person, you don't have that conscious difficulty. You are not conscious that this is difficult for your brain. But your brain does the job. Your brain knows that this is difficult, but I will sort it out. I will make sure that you understand what the other person is saying. Now, how does the brain do that? Now, I said this is really difficult for the brain to make sense of what the other person is saying, especially if a lot of people are talking and the signals are co-articulated. The sounds, you hear all the sounds together in 1 second or less than a fraction of a second, but your brain still makes sense of what you hear, and it gives you the meaning. So how does the brain do that? This is due to constructive speech perception. Speech perception, or understanding, or creating a perception of what you hear. Now it's constructive. If you think of the word construction, so you take blocks, you take wood, you take whatever, what have you. So you take whatever that's around you and build a house, right? You take blocks, you take wood, you take iron, you put them together to make a house. This is called construction, right? It's the same when it comes to speech perception. Your brain, the speech perception system, takes information anywhere it can find it to construct a linguistic perception of the acoustic signal. The acoustic signal is what you hear. The acoustic signal is what you hear. So you hear it, then your brain, the speech perception system, will take information anywhere it can find it, just to make sense, just to construct a linguistic perception, to make something that you can understand it. So what do we mean by that? For example, the lip movement, this is one example. Lip movement, this is one example. So your brain will focus on the lips. So if a person produces or moves their mouth in this way, probably he is saying this word. And you can see it in lip reading. Lip reading. Some people are excellent at lip reading. So the other person would be just mouthing without any sounds. But the other person would say, I think he is saying this, 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 and that. Yeah? This is one way of getting information. The other is the acoustic signal, then context, everything. Okay. Now let's look at this break. I want you to focus on this break, on this video. and I'll come back and explain the whole thing. All right. Now I'm going to show you this video here. Just make sure that it works. Now I'm going to show you a video of a person saying few words or syllables, and I want you to write down or just think about the sounds this person is making. The sounds this person is making. Now, what sound is this person making? Probably you heard it as ba-ba, ba-ba, right? Now, look again. Now, what sound is this person making right now? You probably perceived it as ta-ta or da-da, right? Now, watch again. Now, what sound did you hear? Probably you heard it as va-va, va-va, right? Now, look at this video again. So first, focus on the person. Focus on the person, or it's the same person actually, but look at the video to the right. Okay, first let's look at the right. Sorry, just 1 second. Yes, now look, focus on the person to the right. What sound? Now the middle. Now left. Again, the right. Now probably when you looked at the person or the video to the right, you heard ba-ba. And when you looked at the person in the middle, you heard it as da or pa. To the left, you heard it as va. Right? Now, if I tell you, or just 1 second. Right. Now, when you looked at the person here, or the video to the right, this one here, you heard it as ba. In the middle, you heard it as va, or da, sorry, or ta, and then as va. Now, basically, it's the same sound all the way. It's the same sound all the way. Starting from the very beginning, there. This is the same sound, but you heard it differently. Or let's say, you heard it the same, but you perceived it differently. Alright, now this is magic, right? Isn't it? I'm going to show it to you again so that you focus. It's the same sound, believe me. Right? Now you hear it as Baba. Alright, I'm going to make sure that you listen to it again. Now you hear it as Baba. It's the same sound. It's the same sound, believe me. Again, it's the same sound. Now if you move your eyes, you will hear the sound differently. Right. Now, what's going on? This is called McGurk effect. This is called McGurk effect. So, how come that we can hear the same sound differently? This is because of constructive speech perception. Constructive speech perception. So, when you looked at this person to the right, the person was mouthing ba, ba. Alright? So it's the same sound, but the person who made this video, like, put the audio on different videos. Video number 1, the person was mouthing ba, ba. And you heard the sound as ba, ba. But then, when the same audio was put or aligned to another video in which the person was mouthing da, da, you heard it as da, da or ta, ta, depending on your first language. Then, when the third person or the third video, the person was mouthing va, va. He wasn't saying va, va. He was just mouthing ba, ba. Sorry, va, va. But you heard it as va, va, even though the sound was ba, ba. So what's going on here? If you look away and play the same video, you will hear it as ba, ba all the way. So what's going on? Your brain takes information from everywhere and will try to make sense. So your brain is going to say, assuming that your brain talks, well, I heard ba. But this is not possible because the person is mouthing va, va. So it must be va, va, not ba, ba. Right? So your brain, you will perceive it as va. Even though you heard it correctly, your brain heard it as ba. But then it changes it to a perception, something that you understand. So isn't that interesting? What you hear is not what you perceive. This is very important. What you hear is not what you perceive. And that's why sometimes you have people fighting, because you said something, the other person perceived it differently, misheard you maybe, or maybe misperceived you or your message. Right. Now back to the lecture. Alright, so again, what you hear is not what you perceive. This is called McGurk effect. Again, sorry. This is called McGurk effect. If you watch a video of a person mouthing ga ga together with the audio track of a person saying ba ba, you will hear da da if you are a native speaker of English. If you are a native speaker of another language, probably you will hear it differently, probably as ta ta, not as da da. And this is also very interesting because different people will perceive this new sound differently. You will hear it as da, or native speakers of English will hear it as da. You will hear it as, or perceive it as ta. And there are many reasons for that. Now, the video, sometimes the visual overrides the audio and vice versa. Sometimes your brain says, okay, I'm going to believe what I hear, not what I see. Because what I see, the lip movements, do not go with the audio. So I'm going to believe what I hear. Sometimes it's the opposite. Sometimes the sound can go with the lip movement. But sometimes, like ba, when you say ba, and your mouth moves like this. But sometimes if your mouth says or moves as if it was saying va, and the sound was ba, your brain is going to say, okay, now I have a problem, but I will fix it. I will fix this problem. So a person cannot say ba while biting the lower lip, for example, like this, va. So your brain is going to say it must be va then. So the visual, what you see, will override the audio. Right. Now let's look at another strategy of the speech perception system, which is phoneme restoration. Phoneme restoration. This is also very important and related. Probably we will continue talking about this in the coming lecture. I think today this should be enough for today. Yeah, so this should be enough for today. We're going to talk about phoneme restoration, which is a very important strategy that the brain uses in the coming lecture, lecture number 9, inshallah. So see you in lecture number 9. I'm going to skip some slides here. Thank you very much for your attention. And, sorry, just one second. Yeah, thank you very much for your attention. And see you in lecture number 9, inshallah. All right. Assalamu alaikum wa rahmatullahi wa barakatuh.